A tile floor and a folded blanket can sit in the same room for hours. A thermometer may show that both are at nearly the same temperature, yet bare feet say otherwise. Tile feels cold immediately, while the blanket feels mild or even warm. Your skin is not measuring temperature alone. It is sensing the rate of heat flow. Your feet are usually warmer than the room. When they touch a cooler object, thermal energy flows out of the skin. The faster that energy leaves, the more strongly cold-sensitive nerve endings respond. A surface that removes heat rapidly feels colder than one that removes it slowly, even when both started at the same temperature. Tile conducts heat relatively well and has substantial thermal mass. The first thin layer of tile touching your foot warms, but heat quickly moves deeper into the floor that keeps the contact surface cooler and maintains a strong flow of energy away from your skin. The tile can continue drawing heat for some time. A blanket behaves differently. Fibers trap many small pockets of air, and still air is a poor thermal conductor. Only a limited part of the fabric makes solid contact with the skin. The thin contact region warms quickly, while the trapped air slows further heat loss. Because the heat flow rate falls, the blanket soon feels much less cold. This is also why metal objects often feel colder than wood in the same room. Metal transports energy away from the contact point rapidly. Wood, foam, fur, and layered clothing slow that transfer. Insulation does not generate heat. It reduces the rate at which heat escapes from a warmer body. The original story emphasizes thermal conductivity, but another property also matters: thermal effusivity. It combines how well a material conducts heat with how much energy it can absorb for a given temperature change. Materials with high thermal effusivity pull heat from skin strongly at first contact. This concept explains touch sensation more accurately than conductivity alone. The micro doctor section extends the story to the thermoelectric effect. In some materials, a temperature difference can produce an electrical voltage. Thomas Johann Seebeck demonstrated this in 1821. The effect is used in thermocouples for temperature measurement and in thermoelectric generators that convert part of a heat flow into electricity. The same broad rule remains. When two regions have different temperatures, energy can move and measurable effects can follow. Living organisms also convert temperature changes into signals. Although not by using a simple metal thermocouple, temperature-sensitive ion channels in sensory cells alter electrical activity in nerves. That is how your body detects the rapid cooling caused by tile. The goose bumps that may follow are part of the body's response to cold, not evidence that the tile itself had a lower thermometer reading than the blanket. So the floor is not necessarily colder. It feels colder because it takes heat from your feet faster. Tile maintains heat flow. A blanket traps air and interrupts it. What your skin reports is a thermal exchange happening in real time.